Hello everyone, I'm Naman Bansal and today I'll be talking about our work on the evaluation of multi-narrative overlap summaries. This is a work done by our team at Auburn University. Semantic Overlap Summarization or SOS task is inspired by set theory. In set theory, we have the concept of set intersection. Set intersection is easy to define when you have well-defined entities such as numbers. However, it is not so clear in the case of textual data. A human would mostly express the output in the form of natural language. Thus, we frame the SOS task as a constrained multi-sequence to sequence task where the output text only contains the information that is present in both the input documents. More specifically, given two distinct documents or narratives D1 and D2, the task is to automatically generate a single summary which only conveys the common information provided by both D1 and D2. Here is a toy example of the SOS task, where both articles cover the same event related to abortion but from different political perspectives. One covers from the left-wing media as shown in blue and the other from the right-wing media as shown in red color. The goal of the SOS task is to generate a summary that conveys the common or overlapping information as shown in green text. Here are some of the properties that overlap summary should hold. Output summary should only have information which is present in both the input documents. The output can either be extractive, abstractive, or a mixture of both as per the use case. We also argue that brevity or minimal repetition is a desired property of semantic overlap summarization. For example, if a particular piece of information or quote is repeated twice in both the documents, we don't necessarily want it to be present in output overlap summary two times. And finally, SOS should also follow the commutative property. One of the biggest challenges with this task is that there is no existing dataset that we could readily use to evaluate it. To address this challenge, we collected roughly 3000 samples from allsides.com. Allsides is a news forum that presents information from different sides of the political spectrum, including left and right-wing media. Allsides also provide its own factual description of the reading material labeled as theme description so that readers can see the so-called neutral point of view. Given two narratives, we use the theme description as a proxy for ground truth reference summaries. We further engaged human volunteers to thoroughly annotate our texting samples. The idea was to create a comprehensive testing benchmark for rigorous evaluation. This process helped us create multiple reference overlap summaries for each input pair. In total, each narrative pair had 4 reference summaries, 3 human written and 1 from all sides. In total, we created 411 human annotated overlap summaries. As ROUGE is the most popular metric used today for evaluating the summarization tasks, we first conducted a case study with ROUGE as the evaluation metric for the SOS task. We experimented with multiple state-of-the-art pre-trained abstractive summarization models as naive baselines for SOS task. To generate the summary, we simply concatenate the input pairs and feed it directly to the model to generate the overlap summary. To test the robustness of ROUGE metric for evaluating the SOS task, we computed Pearson's correlation coefficients between each pair of ROUGE F1 scores obtained using all the 4 reference overlap summaries. The corresponding correlations are shown in this table. The average correlation value across annotators is 0.36, 0.33 and 0.38 for ROUGE1, ROUGE2 and ROUGE-L respectively, and thus showing that ROUGE metric demonstrates high variance across multiple human written overlap summaries and is unreliable for the evaluation of SOS tasks. Previous work proposed to assign overlap labels to each sentence within the system-generated overlap summary for the manual evaluation of SOS task. They defined overlap labels as present, partially present, and absent. Label annotators were asked to look at each machine-generated sentence separately and determine if the core information conveyed by it is absent, partially present, or present in any of the 4 reference summaries. More specifically, annotators were provided with the following instructions. If the human feels there is more than 75% overlap between each system-generated sentence, In any reference summary sentence, assign the label P, else if a human feels there is less than 25% overlap, assign label A, otherwise assign the label partially present. Kendall rank correlation coefficient is used to compute the pairwise annotator agreements for the sentence-wise labeling scheme. Table here shows the correlation for both precision and recall, which is greater than 0.5, signifying higher inter-rater agreement. Alternatively, we define a reward matrix based on simple heuristics. This reward matrix acts as a form of correlation between two annotators. For a given sentence, it compares the label of one annotator against the label of another annotator. Once the reward has been computed for each sentence, one can compute the average precision and recall rewards for a given sample and accordingly for the entire dataset. The corresponding reward scores can be seen in this table. Both precision and recall reward scores are significantly high for all the different annotators pairs and thus signifying a higher interlabel annotator agreement. We believe one of the reasons for higher reward and Kendall scores could be that sentence-wise labeling puts a lesser cognitive load on the human mind. It allows us to be more consistent in contrast to single or double scores for the entire overlap summary and therefore shows higher agreement in terms of human interpretation. Subsequently, we work on a new evaluation metric called Semantic F1 inspired by sentence-wise labeling. Here, the idea is to compute the sentence-wise similarity, say cosine similarity between two sentence embeddings, to infer the semantic overlap between system-generated summary and reference summary from both precision and recall perspectives and then combine them into F1 scores. As I previously mentioned, SEM-F1 computes similarity scores between sentence pairs from both precision and recall perspectives. We further converted these sentence-wise similarity scores into overlap labels using various threshold values. Here, we wanted to compare the SEM-F1 inferred labels against the human annotated labels. The table here shows the Kendall correlation between human labels and SEM-F1 inferred labels across various embedding models and threshold values. As we notice, correlation values are consistently high and stable across all the embedding models and threshold values. Again, we show the correlation between human labels and SEM-F1 inferred labels in terms of the reward matrix. Just like Kendall rank correlation, the correlation scores are again consistently high and stable across all the embedding models and threshold values. Next, we want to check if SEM-F1 metric can distinguish between random pairs and real pairs, or to say what is the lower bound. Thus, we compute the SEM-F1 scores for two random baselines. First is random reference. For a given model generated summary of a particular input pair, we choose a random reference summary from all the other pairs in the dataset and use it to compute the SEM-F1 scores. Random output. For a given reference overlap summary of a particular input pair, we choose a random model generated summary from all the other pairs in the dataset. As we notice, abstractive summarization models achieve approximately 40 to 45% improvement over the random baseline scores, suggesting that SEM-F1 can indeed distinguish between the good from the bad. Following the case study based on ROUGE, we also computed the Pearson's correlation coefficients between each pair of raw SEM-F1 scores obtained using each of the four reference summaries. As we notice in the table here, average correlation values across annotators is approximately 0.5 for all the three embedding models and thus suggesting a clear improvement over ROUGE. In conclusion, we make the following contributions in this work. We frame semantic overlap summarization as a constrained multi-sequence to sequence problem and exclusively study how the automatic evaluation of this task can be performed at scale. As a starting point, we experimented with ROUGE, a widely popular metric for evaluating the text summarization tasks, and demonstrate that ROUGE is not suitable for automatic evaluation of SOS tasks. Finally, we propose a new precision recall style evaluation metric called Semantic F1 for the evaluation of SOS tasks. Extensive experiments show that new SEM-F1 metric improves the inter-rater agreement compared to traditional ROUGE metric and also shows a higher correlation with human judgments. Thank you for listening.